8177. Which of the following is a good indication of a malfunctioning fuel nozzle when inspecting the exhaust section of an aircraft turbine engine? A. Buckling of the combustion liner. B. Hotspots on the tall cone. C. Carbon buildup in the exhaust. The correct answer is B. When inspecting the exhaust section of an aircraft turbine engine, hotspots on the tail cone can be a good indication of a malfunctioning fuel nozzle. The fuel nozzle is responsible for delivering fuel into the combustion chamber of the turbine engine, where it mixes with compressed air and undergoes combustion. If the fuel nozzle is malfunctioning, it can result in an uneven distribution of fuel within the combustion chamber. When fuel is not properly distributed or atomized, it can lead to incomplete combustion or localized areas of excessive fuel combustion. These localized areas can create hotspots on the tail cone, which is the rear section of the engine where the exhaust gases exit. Hotspots on the tail cone can be observed as areas of discoloration or excessive heat compared to the surrounding areas. They can indicate uneven or improper combustion due to fuel nozzle malfunction. 8178. The stator vanes in an axial-flow compressor. A. Convert energy into pressure energy. B. Convert pressure energy into velocity energy. C. Direct air into the first stage rotor vanes at the proper angle. The correct answer is A. The stator vanes in an axial-flow compressor play a crucial role in the compression process by converting kinetic energy into pressure energy. In an axial-flow compressor, the stator vanes are stationary blades located between the rotating rotor blades. Their primary function is to guide and direct the airflow as it passes through the compressor stages. As the airflow enters the stator vanes, its kinetic energy, which is primarily in the form of velocity, is converted into pressure energy. The stator vanes achieve this by changing the direction of the airflow and increasing its pressure. By slowing down the airflow and redirecting it, the stator vanes help create a pressure rise in the compressor. This pressure rise is essential for the compression process, as it increases the density and energy of the air before it enters the next compressor stage. 8179. The velocity of subsonic air as it flows through a convergent nozzle. A. Increases. B. Decreases. C. Remains constant. The correct answer is A. When subsonic air flows through a convergent nozzle, its velocity increases. A convergent nozzle is a duct or passage that narrows down in cross-sectional area along its length. As the air passes through the convergent nozzle, the narrowing cross-sectional area causes the air to accelerate. According to the principle of continuity, which states that the mass flow rate of a fluid remains constant in a steady flow, the increase in velocity is accompanied by a decrease in pressure. The convergent nozzle's shape accelerates the airflow by increasing its velocity while reducing its pressure. This acceleration of the air is due to the conservation of mass and the conversion of pressure energy into kinetic energy. 8180. The velocity of supersonic air as it flows through a divergent nozzle. A. Increases. B. Decreases. C. Inversely proportional to the temperature. The correct answer is A. A divergent nozzle is a duct or passage that expands in cross-sectional area along its length. As the supersonic air passes through the divergent nozzle, the expanding cross-sectional area causes the air to accelerate further. In supersonic flow, the increase in velocity is accompanied by a decrease in pressure according to the principle of continuity. As the air expands in the divergent nozzle, its velocity increases while the pressure decreases. The divergent nozzle shape allows the supersonic airflow to expand, which results in further acceleration and an increase in velocity. This expansion converts the decrease in pressure energy into kinetic energy. 8181. The pressure of subsonic air as it flows through a convergent nozzle. A. Increases. B. Decreases. C. Remains constant. The correct answer is B. When subsonic air flows through a convergent nozzle, its pressure decreases. A convergent nozzle is a duct or passage that narrows down in cross-sectional area along its length. As the air passes through the convergent nozzle, the narrowing cross-sectional area accelerates the airflow, leading to a decrease in pressure. According to Bernoulli's principle, as the velocity of a fluid increases, its pressure decreases. In a convergent nozzle, the velocity of the subsonic airflow increases, causing a corresponding decrease in pressure. The convergent nozzle's shape accelerates the airflow by increasing its velocity while reducing its pressure. This acceleration of the air is due to the conservation of mass and the conversion of pressure energy into kinetic energy.